Hello everybody, now we're going to talk about the union bound detection, which is one of the methods of knowing the actual error probability in our detector in an AWGN channel, which is an additive wide Gaussian noise channel or channels. So we will choose the variance of our noise to be equal to n0/2. This is our first condition. It's usually like this with all the problems everywhere, but you never know. In our constellation diagram, for example, for a quadrature, for example, quadrature phase shift keying modulation, we have 4 symbols. Okay. Have this point, we have this point, we have this point, and this point. And as you can see, it's a square, okay? It's a square. Just my drawing is kind of bad, but it is here 1D, here it is a D, and here, and in order to find the distance between this one and this one, we just use the Pythagorean method, and it's of course square root of 2 of d, because d square plus d square plus d square is equal to 2d square, and the distance is square root of that, which is square root of 2 of d. Never mind. Now we're talking about union bound detection. Union bound, and there is the nearest neighbor approximation that you'll see in the next video. But here we're talking only about union bound, and in an exam or an exercise, he will ask you whether you want to detect using want to know the probability of error using union bound or nearest neighbor approximation. So PE for here, for everyone, let's say, in general, it's 1/m, which is the total number of the points that you have, and sum of some probability of x vector x. This is a vector, don't get confused, don't be scared. And this is big, which is this space of symbols, and a is equal to ai. So yeah, so in order to do this, it looks complicated, but it's really not. It's not complicated, but using this rule, you can find everything you want. So m is the number of points. We have in quadrature phase shift keying, we have 4 points, obviously. And we make this, and then look at it. For any probability, you usually use q function, and q here is d. D over square root of 2n0, and we have 2 of this case, so we put 2 times 2 plus we have this one too, and this is the thing, sorry, it's not equal, it's smaller. Our probability of error probability is smaller than this, so we're overestimating it in union bound. And here it's q square root of 2d square root of 2n0. And don't be scared, because usually when we talk about this thing, wait, let's finish this. And obviously this part is only for 1 point, okay? And we want to see what happens, and for this point, and for this point, and for this point, for this point, we gotta take that into consideration. So you multiply by 4, and then 4. And then you get your result, which is literally in every course book. It's qd over square root of 2n0 q square root of 2d over square root 2n0. We can remove the square root of 2's, but I don't know, I just kept them, it doesn't matter. Yes, so we get these, and what we want to do in the q function, you should just put distance over 2 over the variance, the standard deviation, which is square root of n0 over 2. And using that, you get q d square root of 2n0. So don't be scared. It's nothing. So yeah. So this is for QPSK. And in the next video, I will explain how we can get the same result for 8PSK. So if you did understand it, I would also suggest that you still look at the next video just to make sure.